Okay, so good day to our grade 8 Math Science High School students. So let's try to continue answering our problem. We have using two angles of depression. So let's try to solve this problem. An observer on top of a hill, okay, let's say that this is our hill, and here's our person. Okay, on top of a hill, 250 feet above the level of a lake, sighted two boats. Okay, so it's feet 250 feet above a lake, and he sighted two boats. Okay, let's say this is our lake, and this boat Tsip 1, and this boat Tsip 2. Okay, to the nearest foot, you need to find the distance between the two boats. Okay, we need to find the distance between A and B. Okay, so we need to find the distance of both A and both B. Okay, if the angles of depression noted by the observer measured 11 degrees and then 16 degrees. Okay, let's see, for example, that this is the first side and this is second side. Okay, and this is a right angle. There you go. So ideally, that's a right angle. Okay, so let's say, for example, this measures 11 degrees. Okay, so our 11 degrees should be here. Okay, so this is 11 degrees. And our 16 degrees, based from his line of sight here, using angle of depression. So based from the line of sight, this is 11 degrees, and this is 16 degrees. And we need to find the distance between the two boats. So there's a shortcut on how to solve this problem. We can use what method? Since we know that this is already 250 feet, and we know that this could be a right triangle, out of the trigonometric ratios that we have, since we're solving for a side measurement, wherein we have a right triangle, within two right triangles. We have a right triangle within two right triangles. So therefore, what we can do is we can solve for the measurement of this angle. Can solve for the measurement of this angle. I'm gonna write it in blue so you guys can see it. Okay, so we can solve for the measurement of this angle over here and this angle over here. Okay, wait, I'm sorry. We need to solve the measurement of this angle here, from here to here, in order to solve for the angle measurement that we need. Okay, in order to solve that, so to find this angle measurement, you need to minus 11 from 90, right? Okay, we need to minus 90 from 11, since this is 90 degrees. Ideally, this is 90 degrees, and then you have an 11 degree angle here. So 90 minus 11, so that means the measurement of this big angle, so that's 79 degrees, and the measurement of this a little bit smaller angle, so that's 90 minus 16. What's 90 minus 16? So that's 74 degrees. So you have a 74 degree angle here. Now we have two angles, okay, 79 and 74, and they're both our reference angles. So this could be theta sub 1, and this could be theta sub 2. Now we're given 250 feet, and we're given a side measurement that we have to solve. Now, to solve for the measurement of this big angle over here, so that's gonna be 90, okay, minus 16, which is 74. So to solve for the measurement of this side, let's say this is side C. To solve for CA, we're going to use the tangent trigonometric ratio. Why? Because we have an opposite side that's missing and an adjacent side that's given. So this is going to give us tangent of 74 is equal to the opposite side, which is missing, and the adjacent side, which is 250. So therefore, the opposite side is equal to 250 of tangent 74. And it's 250 times tangent of 74. So that should give us 871.85 feet. Okay, so therefore the distance between C and A is 871.85 feet. Now we also need to find the distance between A and B. But in order to do that, we have to solve this big angle right here. We're still going to use the same process, but this time it's tangent 79, which is equal to the opposite side, the big opposite side, all over the adjacent side, which is 250. So therefore this gives us 250 tangent of 79, which is equal to the opposite side, and that should give us 250 times tangent of 79. So that should give us appropriately 1,286.14 feet. So that's a distance of CB. Okay, this very long line. So to find AB, we just simply have to subtract CB and AC. Okay, so therefore AB is equal to CB, this big line here at the bottom, the distance between the foot of the hill to the second boat, minus AC, the one that we solved a while ago. So this is gonna give us 1,286.14 minus 871.85 to solve the value of AB, or the distance between the two boats. So it's 1,286.14 minus 871.85, and that should give us approximately 414.29 feet. There you go. So therefore the distance between these two boats, without directly measuring them, just by using trigonometry, not getting your hands dirty, so we have 414.29 feet. And we're able to conclude that using geometry and trigonometry. That's how powerful trigonometry is in surveying or an application in real life problems. Okay, so let's stay tuned for more geometry videos.